Hello, welcome to today's lesson on concave mirrors. Curved mirrors. Although we mostly associate mirrors with plane mirrors, curved mirrors are very useful. Even though their surfaces are curved mirrors are still governed by the laws of reflection. That is, a curved mirror can be thought of as several tiny plane mirrors, but put together in slightly different angles. There are two types of curved mirrors we will focus on. Concave mirrors. If we imagine a sphere with a shiny inside, and we took a section of this sphere, we would have a concave mirror. These are also called converging mirrors. And a convex mirror, these mirrors are thought to be a section of a sphere with a shiny outside. They are also called diverging mirrors. Some definitions that you need to know. The vertex is the geometrical center of a curved mirror. The center of curvature is the geometrical center of the sphere the mirror is made from. The principal axis is a line that passes through the center of curvature and the vertex. The radius of curvature, r, is the distance from the center of curvature to the vertex. The focal point, f, is a point on the principal axis halfway between the center of curvature and the vertex. This is a real point in a concave mirror and a virtual point in a convex mirror. And the focal length, f, is the distance between the focal point and the vertex. Note, r, the radius of curvature, equals 2f, 2 times the focal length. There are three rays we will use to locate the image on curved mirrors. These are called principal rays. The first one is a ray traveling parallel to the principal axis, which will reflect through the focal point. The third is a ray traveling through the focal point, which will reflect parallel to the principal axis. Third is a ray that appears to travel and come through the center of curvature and will be reflected back in the direction it came from. To locate an image, we need only two of the principal rays. However, if you draw accurately, all three rays should pass at the same point on the image. Also note that we will draw curved mirrors as a straight line. This makes drawing principal rays easier. To make the distinction, we will label each type of mirror we are working with. Furthermore, concave mirrors will be drawn on the right side of our pages, and convex mirrors will be drawn on the left side of our pages. So, to draw our ray diagram, you're going to pick a point on the top of the object and draw two incident rays traveling towards the mirror. Using a straight edge, accurately draw one ray so that it passes exactly through the focal point on its way to the mirror. Draw the second ray such that it travels exactly parallel to the principal axis. Place arrowheads upon the rays to indicate their direction of travel. Once these incident rays strike the mirror, reflect them accordingly to the two rules of reflection for concave mirrors. The ray that passes through the focal point on the way to the mirror will reflect and travel parallel to the principal axis. Use a straight edge to accurately draw its path. The ray that travels parallel to the principal axis on the way to the mirror will reflect and travel through a focal point. Place arrowheads upon the rays to indicate their direction of travel. Extend the rays past their point of intersection. Mark the image of the top of the object. The image on the top of the object is the point where the two reflected rays intersect. If you were to draw a third pair of incident and reflected rays, Then the third reflected ray would also pass through this point. This is merely the point where all the light from the top of the object would intersect upon reflecting off the mirror. Of course, the rest of the object has an image as well, but it can be found by applying the 3 steps to another chosen point. Repeat the process for the bottom of the object. The goal of a ray diagram is to determine the location, size, and orientation and type of image that is formed by a concave mirror. Typically, this requires determining where the image of the upper and lower extreme of the image of the object is located and tracing the entire image. After completing the first 3 steps, only the image location of the top extreme of the object has been found. Thus, the process must be repeated for the bottom of the object. If the bottom of the object lies upon the principal axis, as it does in this example, then the image of this point will also lie upon the principal axis and be the same distance from the mirror as the image on the top of the object. At this point, the entire image is filled in. So this is our entire image, this little arrow right here. So this image, we need to know its size. So size, it's smaller. Its orientation, it's upside down. The type of image, it's a real image. Okay, because it's on the real side of the mirror, and the location is closer to the mirror. All right, so we'll do one more example on the next page. All right, so here's my example. We're going to draw 2 rays to help us, 2 principal rays to help us figure out where this object will be when it is reflected. So the first is parallel to the principal axis, and it reflects from that point off through the focal point. And then you'll just continue it off, making sure to draw your arrows. The second ray travels through the focal point and then back parallel to the principal axis. The third principal ray travels through the center of curvature. It's in a straight line. Travels through the center of curvature and then reflects back the way it came. And then your image ends up where all 3 of those cross. All right, so please let me know if you have any questions tomorrow in class, and we will see you later.